Okay, so it's known that there are 7 defective bookworm e-readers in a production of 10,000. In 2010, 3 million of these e-readers were produced, and Ford High School bought 100 of them. Find the probability that at least one of the Ford High School e-readers was defective. Okay, a lot of information here. Let's see what we found. We know that the probability of a defect, or a defective e-reader, I'll just say probability of defect, and that's what we mean, that we found a defective e-reader. Well, we can find that by saying, well, we know that there are 7 defective e-readers out of a total of 10,000 total e-readers, or 0.0007. That's the probability that any one e-reader is defective. So then we can calculate the probability then of no defect, that we select one of these and it has no defect. And so another way that's referred to in probability is the probability that it's good. If it's not defective, it's good. And for abbreviation's sake, I'm just going to write the probability of capital G. That means a good e-reader. Well, that's the complement of defect. The probability of no defect is the complement of defect. And because any one e-reader is either defective or it's not defective. That's our entire sample space. So this would be equal to 1 minus the probability of a defect, a defective e-reader. So we can calculate that. The probability of a good reader is 1 minus 0.0007, or 0.9993. Okay. Well, in this situation, we had a sample of 100. The school bought 100 e-readers, and we want to find the probability that at least one is defective. Well, what does that mean, at least one? That means 1 or 2 or 3. So we're talking about the probability that you have 1 defective, or they opened the box and they tested them and there were 2 that were defective, or they found that there were 3, or, you see where this is going, or 100. All of them were defective. If we're looking for at least one, these are all the possible outcomes. What's our sample space here? Let's consider that. Our sample space for number of defects is they either found no defects, 1 defect, 2 defects, 3 defects, ... or 100, or all of the e-readers were defective. That's the possible sample space. These are the outcomes. You've got 100 e-readers and you're going to check every one of them as they open the boxes, and you've got some people there that's their job. Turn them on, make sure they're all working, and when they're done, one of these outcomes was what they found, the number that were defective. Okay, so at least one, of course, represents 1 or 2 or 3 or 4, all the way to the highest possible number, 100. Okay, what is not included? The probability of none. So clearly we do not want to do a calculation where we calculate every one of these, right? So let's see what we can do instead. Let's use the complement. And see how that works in this case. Okay, so the probability at least one defective will equal 1 minus the probability that none are defective. Well, wait a minute. If none are defective, what that means is that they opened the box and the first one was good, and the second one was good, and the third one was good, on and on and on. Let's see what we're saying here. So they opened the box, the probability none defective, to come to that conclusion, then you had to find the probability that the first one was good. I'm going to use my G. The first one was good, and the second one was good, and the third one was good, and you can see where this is going, and the 100th e-reader was also good. Well, this is a multiplication rule. And the other thing is, with multiplication rule, we have to consider, are these independent events? What do you think? No, of course not. Because after you've tested the first one, you're not going to put it back in the box and then reach in again. Obviously, you're going to set it aside without replacement. Dependent events. But it sure would be nice if we could treat them as independent events. So let's test the rule that says we want to find out, is our sample size less than or equal to 5% of the population size? Okay? So what we're saying is, remember, there were 100 in our sample. The school bought 100 e-readers. Is that less than or equal to 0.05 times? Now, what was the population? How many? This was a sample out of how many? It says 3 million were produced, and Ford High School bought 100 of them. So this number, the population, was 3 million. So your intuition is probably telling you that this is going to be a yes. But let's go ahead and calculate just to show that 100 is definitely less than 150,000. So now we can say, is that true? Yes. So we may treat these dependent events as independent. Very good. So back to our non-defective and our light blue up here. So I'm just going to continue that line. So the probability G1 and G2 and G3 on and on, well, that's the probability of G1 times the probability G2, meaning the first reader was good, the second reader selected and inspected was good, the third reader selected and inspected was good, ... to the 100th reader was selected and good. But because these are being treated as independent events, then I can look back. What did I say probability of one good was? 0.9993. And I'm not going to write that 100 times. We've seen by now that I can just raise that to the 100th power. Okay, but I'm not interested in the probability that they're all good. That's not the question. I need that information. None defective. I'm trying to find at least one defective, and that was 1 minus the probability of none defective. Let me rewrite that. So the probability of at least one defective was equal to 1 minus the probability of none defective. And we just found that. They would be all good, right? So that equals 1 minus 0.9993 to the 100th power. I didn't really need this number here. Where I need it is in this calculation. Okay, so that results in 0.0676629, or say to 4 decimal places, 0.0676. Okay, you can see here how the use of complements and the rule that allows us to treat dependent events as independent events come together to make this a very simple calculation. Okay, well, I've got a question. Would it be unusual to get at least one defective e-reader in a batch of 100? At least one defective e-reader of this brand of e-readers. What do you think? Well, our rule is it's unusual if less than or equal to 0.05. Anything less than or equal to 0.05, we call that unusual. So, since 0.0676 is not less than or equal to 0.05, this would not be unusual. So that's not that unusual for them to find one defective e-reader in a batch of 100. Okay, so finally I just want to make the interpretation of this, what we found. Just squeeze that in down here. Our interpretation is that there is a 0.0676 probability of at least one defective e-reader among 100 e-readers. That's what we found for this brand, Bookworm brand of e-readers. So in conclusion, that's what we can say. There is at least a 0.0676 probability of at least one defective e-reader among 100 e-readers.